So today we're going to be talking about Boolean logic. So actually, before we get into Boolean logic itself, it's important to keep in mind that everything out there in the world can presumably either be true or false or somewhere in between. Now when we process something and we want to think of it in the most basic terms possible, which is really important when you want to communicate with those computers, we're going to be simplifying and breaking it down into either true or false statements, and each of these statements are what you call propositions. So if I said your best friend is approximately 172 years old, that would probably be a false statement. And I'm hoping that's the case. On the other hand, if I said, say, you're watching a video right now about Boolean logic, that would probably be a true statement, or an instance of a true proposition. So in order to make sense of these propositions, it's useful to actually put it in context, and also be able to relate them using compound statements and conditional statements. Now, before we go a little bit further, it's kind of useful to keep in mind that a lot of the times when we're talking about logic or about a general sort of descriptions and definitions that can apply to statements, we like to use variables. So in this case, because we're talking about propositions, I'm going to say your first proposition is going to be called P, and your second proposition is going to be called Q. Now, one of the instances that may come to mind is the negation or not kind of operation. These are operations you can apply to propositions or statements. And so negation is whenever your proposition is true, the negation of it will always be false. So that's like saying if my proposition is it is sunny outside, then the negation of it would actually just be it is not sunny outside. So if the initial statement is not sunny outside is true, then clearly it's not sunny outside. See what I did there with a double negative? Yeah, so this is the concept behind a negation. Now, going on from there, you also have the concept of a conjunction. So conjunctions are basically true if both your first and your second statement, both your P and your Q, are true statements. And this is where, your compound statements come into play. If any of those two are false, your entire compound statement is considered false. And this is sometimes denoted by a little caret in between these two statements. So the next one will be your disjunction kind of statement. So this is something else. Rather than requiring that both be true, a disjunction only requires that one of your two statements, or at least one of your two statements, be true. And so as a result, the symbol looks like a V, kind of like a big basket that can catch anything. As long as one of those two statements, when your first proposition or whether your second proposition is true, well, then your entire compound statement will be considered true, and it's false otherwise. So moving on from there, the next sort of operation that you can apply to a given proposition is known as your exclusive OR. The symbol looks like a circle with a plus sign inside of it. And so in order for this compound statement to be true, you must have exactly one of your two propositions be true. Meaning only or either P or Q can be true. They cannot both be true, and they cannot both be false. Otherwise, your entire statement is false. Next, you have what is known as an implication statement, and this is where I want to spend a little bit more time. One way to word this as a phrase is P implies Q, and you have an arrow here, and if you notice, that may remind you of a chemical equation, especially if you've taken chemistry class in high school, middle school, or college. So in the sense, it's saying P leads to Q. So for P to be true implies that Q to be true, and if Q is true, it does not necessarily mean that P is true. So what do I mean by all of that? Well, let's say P is you earn a grade A in your math class, and Q is I give you $10. So that's like saying if you earn an A, I promise you $10. That's bribery, by the way. Please don't go and do that in real life. So this is an instance of P implies Q. So what if we took it and looked at it from the other end? So if you earn $10, does that mean you got an A? Well, not necessarily, because if you earn $10, it could be from any other job. Maybe you're babysitting your neighbor. Maybe you picked up groceries for someone else down the street. So that's important to keep in mind. And if you're a bit confused, don't worry. Implication statements are a tiny bit terrifying at first, but just a tiny bit. They do come up when you look at mathematical proofs and theories and so on and so forth. So to help us understand them a little bit better, let's consider what's called a truth table. So for this particular truth table, let's draw 3 columns. The first one has P for your first proposition, the second one is Q for your second proposition, and your third column will be and have the title P implies Q. And so what the table does is for every pairing of values of P and Q, which remember are either true or false, we're going to see what it corresponds to in your implication statement. Alright, so first things first, let's say P is true and say Q is true in this case. So both of them are true. Now say you both get an A and earn $10. And so going back to our initial statement, kind of backtracking here, which can be written as if P then Q, if you earn an A, then you get $10. So in this case, because both are true, the implication statement P implies Q is true. Now going on from there, if you get an A, so P is true, and then if you don't earn $10, have I just lied to you? If I promised you $10, then yeah, I just did. And so we're going to say the implication statement here is false, because what it claimed initially wasn't the case in reality. Alright, so let's consider the next possibility. You don't get an A in math, and yet you still earn $10. So have I just lied to you? Let me repeat myself. I told you if you earn an A in math, then you get $10. Well, think carefully. I didn't say what happens if you don't get an A. So actually, this is still a true statement because once again, you could have gotten that $10 from anywhere else. Alright, so last possible case, let's say both of these are false. You don't earn an A and you also don't get $10. What's interesting here is that it also is considered a true statement, or at least the implication statement ends up being true. How come? Well, if you think about it, because you didn't earn the A, I'm not lying to you. The initial criteria was not fulfilled. Alright, so implication statements aside, what happens if your implication statement actually works in both ways? Chances are you've encountered this type of statement before. So for instance, in mathematics, the idea that the angles of a given polygon add up to 180 degrees seems to imply that it's a triangle. But also, if a polygon is a triangle, this goes the other way and implies that the total angle, the internal angle measure of that shape is 180 degrees. And if you've taken geometry before, you would probably know this is called the triangle angle sum theorem. Well, in this case, this double implication going forwards and backwards is called a biconditional statement. This can be worded as P if and only if Q, or P if Q with 2 F's. Alright, so this is basically equivalent to saying P implies Q and Q implies P. Alright, so as a quick review of everything that we've gone over, we've basically considered this concept of propositions, where these either have true or false values. In order to make sense of these propositions, we have to make relationships between them and also apply operations. So the negation, for instance, is literally quite the opposite of the statement, the not. So whenever your initial statement is true, the negation will be false. And a conjunction is when you're taking these two statements and you're saying, I need both of them to be true. And if you have disjunction, it's like saying or. Exclusive or statements, on the other hand, can only have exactly one of two statements be true, and implication statements call for if this, then this. While your biconditional statements are basically two implication statements smashed together, create an if and only if scenario. So that's it. If you have any questions, please do not hesitate to check out any of the available resources on the Q-munity website. And remember, stay curious and keep on learning.